Okay, our third and final video here for week 5 is going to involve volumes of common geometric figures. So, for the most part, these are things that you probably should know, and if you don't, you probably should be able to figure out pretty easily. Sometimes in AP, they will give you the volumes depending on what they're trying to test. Sometimes they won't. So I would say it's probably in your best interest to know these specific volumes. These are the most common ones. So we need to know what the volume of a sphere is. So the volume of a sphere is 4/3 pi r cubed. So really the only thing you need to know to find the volume of a sphere is the radius, because 4/3 and pi are constants. Well, we were given the radius here because the radius of the sphere goes from the center out to any point on the sphere, and that was 6 centimeters. So the volume here is going to be 4/3 pi times 6 cubed. And 6 cubed is 216. So we're going to get 4/3 pi times 216. Okay, so we can multiply the 4/3 times the 216 and simplify that. Now, one of the things that you will hear me say, I don't know how other teachers might do this, but I prefer to make things smaller before I make them bigger. So instead of multiplying the 4 times the 216 and then dividing by 3, because I'm trying to do this mentally, I'm going to divide the 216 by 3 first, and then I'm going to multiply that result by 4. So 216 divided by 3, I can actually do in my head because 3 goes into 21 7 times, 3 goes into 6 twice. So that's 72. So then I would get 4 times 72. Well, 4 times 72 is the same thing as 2 times 72 doubled. 2 times 72 is 144. Doubling that is 288. So that's 288 pi. And because this is volume, the units are now cubed, so it's cubic centimeters or centimeters cubed. Again, you will hear me try to help you guys work on your mental math as much as anything else. I think that doing mental math and doing it correctly and finding little shortcuts, or not really shortcuts, but more efficient ways of getting through it is really important, especially when it comes to taking an AP test, so that you don't have to think so much. Okay, and I'm actually going to skip number 2 and come back to that one. We're going to go to number 3. Number 3 is a cylinder. And the volume of a cylinder is pi r squared h. And it should be really easy to figure out. If you think of a cylinder as just being a simple disk on the bottom, well, the area of a disk or a circle is pi r squared. Well, then I'm going to take another disk and I'm going to stack it on top of that one. I'm going to take another disk and stack it on, take another one, stack it on, take another one, stack it on. Eventually, what you get out of that is the cylinder. That's a really horrible drawing, but hopefully that makes sense. Think about stacking quarters. If you take the area of one quarter, then stack another one, then stack another one, then stack another one, pretty soon you have yourself a nice little cylinder there. So I'm going to erase that because I do not like that drawing. So really, the area of a cylinder is easy. It's pi r squared, which is a circle, times a height. So in this case, we need the radius and the height. Well, they gave us the height's 10 centimeters. They gave us the diameter, however, of the top. So really what we need is half of that diameter, because half of the diameter is the radius. So our radius here is going to be 2. So our volume is pi times 2 squared times the height, 10. So our volume is going to be pi times 2 squared, which is 4, times 10 is 40. So we get 40 pi. Once again, it's centimeters cubed, or cubic centimeters. Okay, so now the reason that I skipped number 2 was because if you know the area of a cylinder, you can figure out the area of a cone. If you think of a cone as being part of a cylinder, like if I were to draw or sketch the rest of this as a cylinder, like that, where the top of the cone hits the top of the cylinder, really a cone is a cylinder, except that what I've done is I've taken out this and this portion. which happens to be 2/3 of the cylinder. I'm subtracting 2/3 of that cylinder out. So the volume of a cone is exactly the same thing as a cylinder, but it's only 1/3 of it. So it's 1/3 pi r squared h. And that's always the way I've thought of how to find the volume of a cone. It's 1/3 of a cylinder. Okay, so we need the same things. We need r and we need h. In this case, they did give us r, and they did not give us h here. What they gave us was what's called the slant height of the cone. So we actually need to do a little bit of work to find the height, because what we need is we need this piece right here. But once again, they gave us enough information using right triangle Pythagorean theorem here to figure this out. They gave me 6 as a bottom. They gave me 10 as the hypotenuse. Hopefully this is one that you know. It's part of a special 3, 4, 5 multiple right triangle. So that gives us 8 for the height. If you didn't know that when I'm not writing it out, you could plug this into Pythagorean theorem and figure that out. So now we have the height. So let's go ahead and figure out our volume, which is 1/3 pi. The radius is 6, so 6 squared, times the height, which is 8. So we're going to get 1/3 pi times 36 times 8. Once again, use a little bit of mental math. Use a little bit of logic here. I can't take 1/3 of 8 easily, but I can take 1/3 of 36. So let's do that. If I take 1/3 of 36, that's 12. And then I'm going to multiply 12 times 8, which is, let's see, 12 times 8 is 96. So we're going to get 96 pi, and then once again, centimeters cubed. Okay, and then the last one, which really should probably be the easiest one, is the volume of a, well, we'll just call it a box. It's really a rectangular prism, and that's the formal name for it. But the volume of a box. And the volume of a box, probably one of the more common ones to do, is length times width times height. And they've given all that to us. So this is going to be really simple. You can call the length whichever piece you want to. I'm going to call the length 12. The width I'm going to call 4. And then the height of the box is 5. So it looks like we're going to get a volume here of 12 times 4 times 5, which is 20 times 12, which is 240. So 240 inches cubed. And that's it. There you go. You guys have enough information now. You should be able to do some practice problems based upon these.